Hello everyone, this is Mahantesh P. Matad from Sanjay Godath Institute. I am here to explain a topic on FSM design using VHDL. Subject VLSI design, branch electronics, college SJ Attigere. This is for third year engineering students. Out of class activity design 1. Students are expected to come by watching a video which has got FSM design example that will be shown in the next slide. However, learning objective of out of class activities are as given below. At the end of watching the videos, students should be able to explain the difference between Mealy and more FSM. This comes in understand level of Bloom's taxonomy. Second objective is write a state diagram for a given sequential machine. This comes at apply level of modified Bloom's taxonomy. The third objective is at the end of watching this video, students should be able to synthesize the given design for FSM on FPGA. This is again comes at apply level. The key concepts to be covered are Mealy FSM, more FSM and sequence detector. Out of class activity design 2. The video is already given in this link, YouTube. You all of are expected to watch this video given at this link. It has got standard YouTube license. The key concept are introduction to Mealy and more machine that you can expect in the initial part of the video from within 1 to 2 minutes. Second important concept that they have covered are sequence detector using more machine. The second part of near about 5 minutes this will be covered. The third part they have covered how to implement the same FSM on FPGA. This is going to be around 3 minutes. So total duration of the video is 9 minutes. So the assessment will be done in the following way. Students are expected to explain the difference between Mealy and more machine. They are going to write in a book that what are the difference between Mealy and more machine in the form of general block diagram. This will take about 4 minutes. Second one is write state diagram for a given sequential machine. Write a state diagram for a different sequence that is given that is not given in the video. It will take about 10 minutes initially. The third important thing is a student should be able to synthesize this, complete the design for a given sequence detector for FPGA implementation. This will go up to 20 minutes for an initial designers. In class segment, the learning objectives of in-class segments are solve real-time scenario problems involving sequential design using FSM. This will come at a higher cognitive level of modified Bloom's taxonomy, that is analyze level. Second objective is implement FSM design using FPGA. The key concept covers are use of FSM design in real world problem solving, implementation of the same thing using FPGA. In-class activity normally consists of higher level cognitive levels like analyze to apply. What I am using here, peer instruction for concept clarification and think pair share for real world problem solving. Peer instruction strategy consists of the questions like given below. For example, in more machine, output depends on. Here we have 4 different options. Students are expected to give their individual opinion and then come to the conclusion that which one is right upon discussing with the other peers. So what exactly student does is given here for the given question. Each student will first vote their opinion, then they will discuss with peers and come to consensus, listen to the instruction explanation. TPS activity, one seed question is given, write FSM for NRZ to Manchester code conversion. This example is taken from Roth book. The fundamental diagram and expected waveform are shown below. So this NRZ code for a given binary sequence will be converted into Manchester. Manchester sequence is given here and the basic block diagram is shown here. So the first think activity, think strategy, TPS activity consists of think activity first. After posing the question, students will start thinking upon it, and students are expected to write state machine for a given example individually. Next one is pair. The instruction given by the instructor is now pair up and compare your answers. Agree on one of the final answer. While students are going for their answers, instructor goes around 2 to 3 sections, see what they are doing. The expected answer is given here. The last activity and very crucial activity of the TPS strategy is share. It will take around 8 minutes for this example. Student will share their designs in the class and instructor will give the pros and cons of each and every design. So at the end they will conclude that which design is good. This activity has a justifiable output. In both the above strategies, students are required to go beyond mere listening and execution of the prescribed step. They are required to think deeply about the content they were familiarized in out of class and do higher order thinking. There is also feedback provided by instructor summary and peer discussion. This slide, what I have presented are directed by, and I have taken a reference from IIT Bombay lectures as in-class activity and out of class activity. Thanks for watching.